So this is somewhat a continuation of the discussions earlier about high replay lags that I've observed testing the two logical replication solutions. And what I've tried is I've played with different synchronous commit settings. So this works in PostgreSQL through a feedback protocol. So if synchronous commit is enabled and there are any replicas that are mentioned in the synchronous standby names parameter, I believe. Oh, there is one more attendee. Hello there. Then PostgreSQL will wait before sending out the commit confirmation to the client until all of the replicas in the synchronous standby name setting have sent the necessary feedback to the, well, let's stay with the names of primary and replica for now. So basically the primary will wait for the replica to confirm that it has either written the transaction to its own disk, or that it has flushed this to the disk, or that it has applied the change to its own buffers and so on, so that it is visible to new transactions that are created at the subscriber, at the replica. in streaming, at least this is how it works in streaming replication. Basically, there are some other nuances that I would go into that I've discovered. So I've run some benchmarks on different synchronous commit settings, and let's jump through them like this. Maybe it's a little smaller. Okay. So for my custom benchmark, which is using PG bench and very, very short transactions, a single insert statement in each transaction here only. So on my machines, I averaged roughly 75,000 transactions per second without waiting for any feedback. And when waiting for the remote write feedback from PostgreSQL in-core logical replication, then this dropped to 35,000, 34,000 transactions per second. And for remote replay to only 30,000 transactions per second. But there is one other synchronous commit level that we can configure in Postgres, which is sort of the opposite of off. It's on. And when trying to set this to on, we see that the number of transactions per second that the benchmark is able to run on average drops significantly and drops way below the remote replay synchronous commit level. Usually one would imagine that the remote replay level which waits for the replica to also make the changes available to clients, that this would lead to the largest drop in transactions per second. But something else is going on here. The main reason for this very bad transactions per second performance is obviously the very high latency here. And then there is another configurable. So that's the first thing that I looked in. Synchronous commit at the subscriber, and then I figured out that, so no, the first configurable is the synchronous commit in the publisher, which is the primary. In regular streaming replication, this is the only place where you can change synchronous commit. So that's where I started. That's where I got these weird numbers. Then I figured out that there is a way to change the synchronous commit configuration in the subscriber as well. And this is something that similarly exists in PG Logical. And the synchronous commit setting in the subscriber, so that is on the receiving side, on the replica, controls whether the apply process in the replica will wait for the transaction to be written to disk or flushed to disk, or perhaps replayed by another cascading replica in relation to this local disk. So if I simply have a single primary and a replica down below in logical replication, then first the primary will wait for the feedback from the replica, and the replica will run this transaction, and depending on the synchronous commit setting in the subscriber, the replica will either send out all the feedback and finish its replaying of this remote transaction without waiting for the commit to be flushed to the disk, or it can be configured, for example, setting this to on, to wait until the data is also flushed to the disk at the replica. And that's what I tried here. I've set synchronous commit in the subscriber to on. So this means that the replica has to wait in its apply process for the transaction to be written to the disk and flushed to the disk, which it normally doesn't do. And then if we take a look at the synchronous commit settings at the publisher, here now we see that the numbers are much more reasonable. And the question to me was, why is this so weird? And it turns out that the sending of the feedback for logical replication perhaps doesn't perfectly match the sending of feedback for streaming replication. So in streaming replication, as I said, or let me start a different way. This feedback protocol was first developed only for the streaming replication, the binary replication. And there it made sense to either wait for the replica to have written the transaction log message to the disk, flushed it to the disk, or applied this transaction log itself. And so these same feedback messages are also sent by logical replication, both by PG Logical as well as the logical replication in PostgreSQL core. But they are sent at different times. I mean, obviously the mechanism is different, so there is no perfect analogy for this, no perfect match when to send this. But as far as I've figured it out, the remote write logical sequence number feedback is sent at the point at which the logical replica simply receives a transaction from the network. So transaction comes in via network, the write feedback is instantly sent out. And the remote replay feedback, which is usually the last kind of feedback that is sent in binary streaming replication, this feedback is sent when the transaction, the replaying transaction at the replica finishes, because that is obviously the point at which other transactions would be able to see the changes. So logically, this makes sense to send the remote replay feedback as soon as the replaying transaction is finished. But what about the flushing to disk? Well, in the default case, the replay worker, the replaying, the replay process does not wait for the flush operation. But to send at least some feedback for the last flushed logical sequence number, both PG logical and in-core logical replication regularly look at the transactions that they replayed recently, and then it looks up if those transactions have been flushed to the disk in the replica. And if that is true, then it sends the matching logical sequence number in a feedback message that this is now finished. But this process only runs sort of regularly, irregularly, every once in a while, and that is obviously not happening often enough. I think this is mostly a crude hack to ensure that at least some update on the replay LSN is given in case you have some monitoring, for example, on this. This wouldn't fall terribly behind, but so far for using synchronous commit, this doesn't really work very well. Synchronous commit, waiting for the replica to flush. And so then that brings me to the main point of this discussion, which I would love to have, but we'll see what happens of it. What comes of it is that in the PostgreSQL documentation, there is roughly this matrix. I've copied this and prettified it for my slide here. And so the implication here is that setting synchronous commit to on at the primary means that the transaction is durable at the standby after the standby crashes, the postmaster process dies, and that it is persistent even if the operating system dies or the machine just goes up in a ball of fire. Well, in that case, the disk would maybe be toast, but that's another topic. But this is sort of well, I think it's not valid like this. When looking at this page in the official documentation, looking at it with the eyes of a little bit experienced DBA, it might become obvious that this matrix was primarily written for the binary streaming replication and not so much with logical replication in mind. And these issues are, as I said, because the same levels of feedback are recycled, but they are sent essentially at different times. And so then for the synchronous commit setting, if it's set to off in the logical subscriber, in the replication, the replay worker, then I think this matrix would have to look like this. So for remote apply, at the primary, we have at least standby query consistency, which is that new transactions at the replica will see the newest state, but because the replay worker does not wait for disk writes or flushes by default, these 2 points here, that the standby is durable after postmaster crash and the transactions durable on the standby after an operating system crash, these two would have to be false because this is actually not guaranteed for the configuration, the default configuration where synchronous commit is off. If synchronous commit is set to at least local in the logical subscriber, then all of the implications or guarantees of this version of the table still hold. But this is my main point of discussion on the consistency topic. Are there any ideas, any thoughts, any remarks? Mr. McAllister, Grant, what do you think?
Well, this is interesting. I mean, it seems very confusing, if nothing else, right?
Yeah, definitely.
Because I mean, like you said, I mean, a lot of this stuff, like mentally, I map to the physical replication, right? And I kind of had a really good map in my head of like, okay, this is what you would use and how you would tell people to do things. And I don't think many people use remote apply because it's pretty dangerous from a primary perspective, right?
Yeah.
But the whole, subscriber setting is because I definitely wasn't aware of this. It's kind of interesting.
Yeah. So let me, because I've talked so much about the documentation. Synchronous commit. Let's look at this. This matrix. Here it is, but let's find it in the official docs. And I mean, looking for logical in this context, nothing shows up in this paragraph about synchronous commit concerning to logical replication. So there is definitely a lack of things that are documented here. And this is all about the characteristics of the streaming replication. Let me.
Yeah, I'm looking at the create subscriber one, and it doesn't have a lot in there, does it?
Yeah. So here's the synchronous commit setting, and the default value is off, as I've said, and they say it is safe to use off for logical replication. If the subscriber loses transactions because of missing synchronization, the data will be sent again from the publisher. So this is assuming some kind of logical replication which you might be using to feed data into a business intelligence data lake, something like that. You probably already have high availability for your primary cluster. I think this is the assumption for this paragraph here. But if one were to think of using logical replication as the only means of replication in general, as the only means of high availability, then this is probably a bold statement.
Yeah, and it doesn't even really talk about the other settings, does it? Like,
yeah, I mean, it links to the synchronous commit parameter because you can use all the same ones. I mean, this is
but
also.
But it doesn't say what they do, though, right?
Well, it works. I mean, even if when using any of the replication systems, and the primary system-wide has synchronous commit set to on, or maybe to remote apply, then in my own transactions, I can still specify I want synchronous commit to off, or vice versa. If the global setting is synchronous commit is only flushing it locally, writing locally, or maybe set it to on so that it is flushed locally. No, hold on. On also waits for the replica. Yeah, anyway. So local. Synchronous commit is set to local, and then I can specify a higher level in my transaction if I so desire.
Right.
But yeah, perhaps the documentation should be more verbose about that as well. That this is essentially the same mechanism as for transactions.
Yeah, I mean, I think this is one of those cases where the documentation, in some cases, is sort of like on the physical side is fairly precise, but doesn't actually help someone who doesn't understand the semantics very well to get the desired outcome.
Yeah.
And I would say that's probably doubly true of, like you said, of the scenario where you're saying, I'm using a logical replication as my durability availability means. This would definitely not be clear.
Yeah.
Yeah, and I hadn't actually thought, because I mean, most of our use of logical replication is as is a streaming means of getting data somewhere else, not as a synchronous replica for durability.
Yeah.
But we have talked about using it that way for other things. So, I mean, especially I think when we start talking about, people doing more stuff with logical as we get closer to having a full, a completer logical replication story for things like major version upgrade and stuff, people may be like, hey, I'll just use logical all the time, right?
Yeah.
If it works from a transaction rate perspective and the other things. Yeah, that is interesting.
Okay. You don't happen to have some notes already? Otherwise, I would start some now, I guess.
Yeah, I don't. Yeah. I
What's
was a little late
the
to your talk because I had an overlapping meeting.
Oh, okay.
Yeah.
No, this is for 2020. Yeah, so now I've talked more about the origin filtering and consistency, but
Yeah.
well, I will
Yeah,
touch on the filtering in a moment, perhaps.
sure.
I think the origin filtering would be a nice thing to have, but the consistency issue is already present.
Yeah.
So first talking point, consistency. Let me share my notepad. Mm,
Does the subscriber setting always overwrite, like over the setting on the overall setting on the publisher?
yeah,
Yeah.
just
Okay.
just like any transaction that you open and change.
Yeah.
This
Yeah. Okay.
does, yeah. Um,
Yeah, as someone that ran databases for a long time, I think the per transaction synchronous commit settings are somewhat evil, but
yeah. This this is sort of difficult to get into a single sentence. Need to think of something else to write here.
yeah.
Can I speak?
Please do.
Okay, so I'm a little bit late for this section, but I just have 2 comments regarding the feedback. We had a discussion about that while we are discussing a feature for 15.
Yeah.
That's the skipped empty transactions. Some people raised some concerns about that, and we realized checking some benchmarks that we have some issues with the feedback mechanism. So we probably need to redesign this mechanism. Feel free to make a proposal. So if you read that discussion, I can check the links for you. You will see some ideas. I think Andres, myself, Amit proposed some ideas, and it will be interested to implement something for it. What else? We also had a bug that was fixed recently that is also related to this feedback mechanism. When we have a long transaction. So it was a long discussion. I can certainly check the link for you. And
okay, so
it also
note
exposes,
that you will perhaps add some links.
Oh yeah, and it also shows some weakness of the current feedback mechanism.
Yeah.
So we certainly need some improvements in this feedback feature, because it works for the physical replication, but it's not so ideal for logical replication. At least in the 15, we have the skip empty transactions. that will improve some workloads and also improve the way we provide some feedback to the upstream.
Mm.
So it's not so bad in the 15 as in the previous version.
Okay, yeah, I tested this for version 13.
Okay.
And there it was really quite bad. So I showed some numbers earlier. I had 75,000 transactions for synchronous commit off, 34,000 transactions per second for remote write, and only 158 for synchronous commit set to on. And so this is every few cycles the apply worker checks a list of transactions that it has not yet sent out the flush LSN feedback. And then it looks up if this transaction has actually already been flushed to the disk. And while looking at that, I think I saw some possible inefficiencies already, because I think it just looks at the most recent logical sequence number, the most recent transaction that was replayed. And if that is not yet flushed, I think it looks at the next one and so on. I was thinking maybe it makes more sense to select a random transaction or something else, or maybe alternatively just get the latest flushed LSN from the replica itself and then find all remote LSNs that then could be acknowledged, because the LSNs only go up. Yeah, but that's
I added the links to the chat.
thank you. I guess for empty transactions, there would just be nothing sent, right? If I guess that's for transactions that are skipped on some condition.
Yeah.
I'd have to look it up, yeah. Okay. Right, any other thoughts? Are you still seeing my screen share of the Visual Studio Code? Okay.
Yeah, looks good. I only have one L in my name, but otherwise.
Oh, sorry.
No problem. I know a lot of people
I
have too.
I was guessing, and then I was planning to look it up, but
Yeah.
Did I forget anything that you said? We discussed a few things, and I'm terrible at.
Yeah, I would say it wasn't that I'd
things.
never thought about these issues, but I never thought about these issues in terms of the differences, right?
Yeah.
In terms of the differences with logical, because it's like it is.
Yeah, the terminology is kind of confusing.
Yeah.
We have a glossary, and maybe you can also improve it in some way. I checked the glossary and it says that standby refers to replica. So I don't know if we have logical standby in the documentation. I didn't check that, and physical standby. So we have this standby terminology in that table that you shared with us. And maybe it's just a matter of saying physical standby, blah, blah, blah.
Yeah, but I mean, this kind of table is sort of useful, and there might also be people that are sufficient that are fine just having the apply feedback, for example. But yeah, there would need to be 3 or 4 different variations, one for physical replication, one for logical replication with the default setting, synchronous commit is off in the subscriber. One for synchronous commit is local and on and so on. Because having it local just waits for the write or not. No, I'm not too sure. Local behavior needs to wait for local flush. Okay, so the thing would be the same for all synchronous commit settings in the subscriber that are other than off.
Yeah, and local is just such a weird term in the subscriber, right?
Yeah, definitely.
Like,
and at all that there are 2 different settings. Why does this not just simply bubble down?
Right.
And if it's too confusing for that particular section, the GUC section, maybe you can provide this same table in the logical replication documentation, for example. So you don't confuse people that are just want to read about synchronous commit for physical replicas, for example. And of course, fix the terminology in that table.
Hold on. Specificalities? I don't know. What about the terminology you don't like that says standby, right?
Yeah, if you check the glossary, it just says standby, and it refers to replica. And if you read the replica definition, it mentions logical replica and physical replica.
Okay.
So maybe in that table, you should refer to physical standby instead of just standby.
All right. Maybe just some quick thoughts about the origin filtering, because I actually have to probably bring my son to bed pretty soon.
We have 12 minutes.
Yeah, well, the issue is my girlfriend wants to go to the cinema, but yeah, anyway. So yeah, because for my thesis, I also looked at sort of, can we do somewhat multi-master using just basic logical replication. I mean, of course, for multi-master, usually you'd also want DDL replication and not only DML. So replication of the table definitions and so on, which we don't yet really have. But just multi-master, or rather, let's call it update everywhere, where you can issue changes at any of the logical at the instances, and it is logically replicated. And I've tried that using PG Logical, and there exists an option to filter based on the origin ID. And then I looked for that in PostgreSQL itself, and it is not there. But this is really a very, very simple feature to add. So all transactions that did not originate, so assuming I am a database node, all transactions that originate at my node have the origin ID of 0, and those that are coming in from somewhere else have a different origin ID. And in PG Logical, you can specify certain IDs to filter, I believe. But
yeah,
I didn't find a way.
Has this, sorry, PG Logical 3 has this feature.
Yeah.
And talking about the core, we had a ongoing discussion about this topic. Let me check the URL. But my point is, maybe you can check this discussion.
Yeah.
And this particular discussion is regarding only local. So you can turn on and off based on the local.
Yeah.
I didn't comment on that thread yet because it's a long thread and I don't have much time right now, but it's on my list to check it out. And in my point of view, I think that just have an option for the local on-off. It's not too generic for this specific topic because we are talking about replica origin. So in my opinion, we should support general filtering. I mean, filtering from different origins instead of just checking the local one.
And is that filtering on the destination or on the original, on the publisher?
The origin. In the publisher,
in
yeah.
The open
publisher,
source, yeah, in the open source version of PG Logical.
The output plugin has this entry point that, for example, if you are a subscriber, you can send to the publisher the origins that you want to filter out. So on the publisher, you can check the origin of that transaction, and then you filter out instead of sending the transaction and filter it on the subscriber.
Yeah, okay, good. That's how I assumed it would work, but I just want to check.
Yeah, so Julian, I think the best thing to do is to jump into this thread that I pointed out and implement. Yeah, that's it. I implemented this particular feature for a product some time ago, some years ago, and it's pretty straightforward to do. It's a small patch, but maybe you have to design it carefully to not paint ourselves on the corner. Like I mentioned, the local case. Avoid two parameters, one of them to general origins and another one to the local case.
Maybe you can enlighten me because I didn't figure this out. How is the origin ID decided? I think that is the origin ID is increased every time I create a new publication, I believe. Is there a way to influence this so that I can specify I want this origin ID to be 42 so that I can configure my replica to filter this out or something like that?
Yeah, so basically when you create a replication on the subscriber, if you check out the code, you will see that when you create subscription, behind the scenes, you create a replication origin. So it decides it for you. And you have to have a way to get that information. And then in some way has your replication setup, knows that, and share this information with the other nodes that you want to build your cluster, let's say.
That's why.
So basically you have to implement something on the top of that to handle your replication directions. That's basically
so, I mean,
what you need.
If I wanted to create a cluster, an update everywhere cluster, maybe, then I guess my first thought would be to just assign each node. So I have node 1, 2, and 3, perhaps, and so I give them origin ID 1, 2, and 3. Do you think it would be possible to have this in the subscription creation part? Maybe there would have to be some specific range that you must adhere to not interfere with anything else. Obviously, you couldn't choose 0.
Yeah, I mean, when you create a subscriber, you create a replication origin. That's a name, it's an OID.
Right.
And you also have a name for the replication origin. So you don't refer to the OID outside that particular node. You only refer to the name of the replication origin. So, like I said, using this infrastructure, you have to build your replication solution. Of course, to be as simple as possible, you can use the OID, but it's not ideal. If you read the code, you will see that it does not recommend you to use the OID directly into your solution, because you can have the way that it's implemented, you can have the same replication origin for multiple nodes.
Obviously.
If you check the algorithm, you say that it will get the next free OID that you have, instead of assign one that you want, for example. That's what I did when I built a similar solution. I just changed the way that you create the replication origin. I mean, I assigned the numbers. So for example, I say, hey, this node will have the number 1, 2, 3, and this other one will have the 6, 6, 4, for example, and so on. But maybe
perhaps sorry.
No, Continue.
Perhaps it would be way better from an administrative human interaction standpoint to have such a filter, and you would create that filter on your subscription. You would tell the filter, you would give it names or perhaps even a regular expression for origins, and then the subscription worker would have to look up if this origin ID is associated with that given name, for example.
Exactly. Use the names.
Okay. Any other ideas? Well, I mean, if anything still comes to your mind, you could, of course, always edit the wiki afterwards.
We are out of time. Maybe you
Yeah.
have to move this discussion to that thread. But
Yeah.
that's the basic idea. I want to think more about this topic. So we have general feature for build multi-master replication, for example.
Yeah. Yeah, I mean, the question is, does one implement this right now? Because I'm pretty sure this would be something that's useful to have at some point in the future when perhaps thinking of creating a sort of eventually consistent update everywhere cluster using logical replication. I mean that's basically already possible in.
Yeah, we
in
certainly
PGLogical.
need some basic infrastructure for that, and this is one of them. The other one is conflict handling.
Yeah.
And I think there is another thread about multi-master replication, but I think we are far from an implementation for multi-master replication. But before that, we need the infrastructure. Without the infrastructure, I think it's
and to quickly recap, I think you also said that you think perhaps a simple just ignore all non-local origins option would also work.
No, not ignore, but we have any special. We have a parameter to filter the origins, and we have a special value for local, for example. If you want to filter local, you add this special value that could be local, and you filter out local instead of, like I said in that thread, it was suggested to have a parameter for control if you want to filter the local or not.
So looking at PGLogical, you can specify the forward origins, which is either an array that contains the string all, I believe, or probably an array of integers. So if you only specified 0 in there, then I think it would only forward all locally originating transactions.
Yeah.
And that's something that my brief 5-liner patch that just basically looked at the origin ID in the wall center in the output plugin, and if the origin ID was other than the 0, it would just skip this transaction. So that essentially skips all non-locally originating transactions, and that gets rid of this echo chamber or infinite recursion issue.
Yeah.
So that could
That's
be a
it.
simple Boolean, and that doesn't need parsing of origin names or something. Although I agree that would be the ultimate goal, probably. Perhaps one could have both at different points in time. But subject to discussion, I guess. Okay, well, let's close this up then. Thank you for your input.